All right, we've worked on simplifying rational expressions, multiplying, and dividing. Now we'll end this lesson, or actually, excuse me, we will move to addition and subtraction of rational expressions. At the end of the lesson, then we have to talk about solving rational equations. I kind of got ahead of myself there. Okay, so we are adding a fraction to another one. The reason why you are able to add here is because the denominators are the same. Remember, the only way you can add and subtract rational expressions, or if you'd like to call them fractions, that's fine. The denominators have to be the same, okay? We are not cross canceling because this is not multiplication. Remember, we only cross cancel or divide out common factors between factors. These are not factors because it would have to be multiplication. This is addition, so these are different terms right now. Okay, everybody, we know that whenever you have a common denominator, you keep it, right? You keep the common denominator, and then you just add the numerators. The numerators are not like terms, so that's the best you can do. So it's as straightforward as that. You just finished adding, so good job. You're not done, however, just because you should work on simplifying if you can. The numerator factors as m times m plus 8 by factoring out the GCF of m. The denominator is a difference of two squares, so it factors like that. And then I notice now that, oh, we have common factors. So now that it's everybody's factored, now I can cross cancel, right? So now you're left with m over m minus 8 as the simplified answer, all right? Now, what you're going to see for the next couple examples is the denominators are not the same. So you're going to have to work on finding the LCD, and so that you can have the same denominator and then add or subtract. All right, you have 13x over 15y squared plus 11x over 25y. Obviously, these denominators are not the same, so you are not allowed to add these fractions. So what we'll do is we'll find the LCD. All right, if you need help finding the LCD, you can listen to the following explanation. Here is 15y squared. That's one of your denominators. 15y squared factors as 3 times 5 times y. That's prime factorization. The other denominator, 25y, factors as 5 times 5 times y. The LCD happens to be the product of each different factor the greatest number of times it appears in any one factorization. That sounded like a mouthful. Let me break that down for you. The LCD is the product of, stop right there. Okay, so we're going to multiply. What are we multiplying? Well, it's the product of each different factor. So I have to take every different factor and include it in my LCD. How many times do I include it? Well, I include each different factor the greatest number of times it appears in any one factorization. Let me walk you through that. So, I see a factor of 3. So 3 has to be included in my LCD. How many 3's? Well, just once, because it only appears one time in this factorization. So I have a 3 in my LCD. I see a factor of 5. So I have to put a 5 in here. How many times? Well, in this factorization, 5 appears once. But in this factorization, 5 appears twice. So the greatest number of times that 5 appears in any one factorization is twice. You would not say it appears 3 times because these are two different factorizations. So consider each factorization separately. It appears once. Over here, it appears twice. So you'll need 2 5's. Following that thinking, you'll need 2 y's in your LCD. So the LCD then, when you multiply all of this out, you get an LCD of 15y. Oh, excuse me. I wrote something down wrong. Excuse me. I think I got ahead of myself. Y times y. Yeah, I think I had y squared there. All right. So the LCD then is 75 y squared. This is the LCD. This is what you need each of your denominators to be. Okay, so then the question becomes, what do you multiply this denominator by in order for it to become the LCD? 15y squared times what gives me 75y squared? Well, this is what I want you to see. This much right here that I'm highlighting, 15y squared, that much that I just highlighted is 15y squared, right? 15y squared. So it's right here in the prime factorization. This is why I'm such a fan of prime factorization. This is 15y squared, so the answer is right here in front of you. 15y squared times 5, do you see that leftover factor? Times 5 gives you 75y squared. So what do you multiply 15y squared by to get 75y squared, which is the LCD? By 5. And you and I know, it should go without saying at this point, that if you multiply the denominator by 5, you have to multiply the numerator by 5. Now off to the next fraction. What do you multiply 25y by in order for it to become the LCD of 75y squared? Let me use the same thinking. This much here that I've highlighted is 25y. So 25y times 3y gives me 75y squared, which is the LCD. So I'm going to have to multiply by 3y, of course, in the denominator and the numerator. So you can see this numerator becomes 65x over 75y squared plus 33xy over 75y squared. So this is the idea. What you just did is you rewrote both of these fractions as equivalent fractions that have the same denominator. Now that they have the same denominator, now you can add. So this numerator plus this one over the same denominator. All right, everybody? And at this point, you're done. The problem is already simplified. 65 and 33 do not share any common factors, all right, other than x. Or this term and this term, they have a common factor of x. But even if you factor out the x, it will not help you simplify this any further. So this is already simplifying. Very good, you guys. All right, so example 9. What we're going to do is we're going to subtract a rational expression, this rational expression, from this one, all right? So the idea here is, you can clearly see that the denominators are different. So you and I will work very hard to find the LCD. Once we have the LCD, we can create equivalent fractions, and then we can subtract. So let's go for it. All right, we'll find the LCD the same way we found the LCD in the previous problem. I wrote down each denominator, and I'm going to factor each one, right? Prime factorization again, remember? This is how that first denominator factors. The second denominator is a difference of two squares, so it factors like this. All right, so the LCD is, remember this, the product of each different factor, the greatest number of times it appears in any one factorization. All right, I need an x plus 2 in my LCD. X plus 2 shows up once here, shows up once in this factorization. So then x plus 2, I only need one copy of that factor. X plus 3 shows up only once, so then I only need one copy of x plus 3. Now, I already have x plus 2, right? I already have that copy. I need x minus 2 in my LCD as well. X minus 2. All right, let's go back to our problem now that we know what the LCD is. All right, everybody, what I've done is I've rewritten each denominator in its factored form, okay? So I have each denominator already factored. Now, it's time to rewrite these fractions as equivalent fractions with denominators of the LCD. All right, so this is what I need to do. What do I multiply this denominator by? Everybody keep in mind that this denominator is this denominator, right? This denominator is equivalent to this one. So what do I multiply this denominator by in order to get the LCD? Well, I always tell my students, look at which factor is missing. What I mean by that is x plus 2. Oh, this denominator already has an x plus 2, so that's good. X plus 3, this denominator already has x plus 3. You know what this denominator does not have, or what it's missing, if you will? It's missing an x minus 2. So I'm going to multiply this denominator by x minus 2, and then it'll look just like the LCD. Of course, you and I know that if you multiply the denominator by x minus 2, you're going to have to multiply the numerator by x minus 2. As far as the second rational expression goes, I have an x plus 2, I have an x minus 2. What this denominator here is missing is the x plus 3. So if I can squeeze it in here, I'm going to multiply the numerator and the denominator by x plus 3. All right? So that's what I'm multiplying each of these rational expressions by. Notice that you're multiplying by 1, because x minus 2 divided by x minus 2 is 1. X plus 3 divided by x plus 3 is 1. So in essence, you are not changing the value of these rational expressions, because whenever you multiply any expression by 1, its value stays the same. All right, everybody, this is what we have. X plus 1 times x minus 2, right? And then minus x minus 3 times x plus 3, all right? Now notice that the denominators are the same. They're the LCD. Let me move this up for us now, okay? I hope that's clear for you. Now the next step is to distribute these numerators. So it's x times x, times negative 2, 1 times x, 1 times negative 2. Over here, x times x times 3, negative 3 times x, negative 3 times 3. Do not distribute the denominators. The denominators, keep them the same and keep them in factored form. All right, so then what you get is x squared minus 2x plus 1x minus 2 over the LCD over here. You get x squared plus 3x minus 3x minus 9 over the LCD. Okay. Let's combine like terms now. And the like terms I'm talking about are these. These are like terms. Over here, these just cancel because they're opposites, right? So then what you're left with is x squared and then minus x minus 2, right, over the LCD. All right. And over here, you're left with x squared minus 9 over the LCD. Alrighty. Okay, cool. Let me move this up more. Now notice that now you have two fractions, right, with the same denominator. So now you're able to actually go through with the subtraction. So you're going to have the first numerator, x squared minus x minus 2, minus the second numerator, which I put parentheses around because you have to make sure that you are subtracting x squared and you're subtracting negative 9, right, over the LCD. The same LCD, right? So you keep the common denominator. Remember, multiplication is commutative, so you can rewrite the factors. You can write them in whatever order you want down here. All right, so be careful that you are distributing that negative, right? That's something to be very, very cautious about. So then you end up with x squared minus x minus 2 minus x squared right here plus 9. That's something to be very, very, very aware of, all right? Watch your signs. Okay, so I hope you can see at this point that positive x squared and negative x squared just cancel. Like terms, though, you have a negative 2 and a positive 9, which I believe just gives you 7, right? Let's move this up a little bit more just for me to write my final answer. That should do it. So then you end up with negative x plus 7 over the LCD. And this, ladies and gentlemen, is the final answer. You have subtracted one rational expression from the other. You had to find the LCD. You had to rewrite the original rational expressions as equivalent rational expressions that have the LCD as their denominators, and then you can do the subtraction. It's kind of a lengthy process. You want to be very, very careful throughout the entire process, especially with your signs. Okay, everybody, we've walked through how to simplify rational expressions. We've talked about multiplication, division, and addition and subtraction of rational expressions. This is the end of this lesson, and I'll catch you in the next.